Thank you to LLS for inviting me along to give my perspective on the soil water outlook. The new SWOT 21 tool sounds dangerous, but it's not that dangerous. And what I wanted to do was put that into context of the forage base. So for the Beef Producers Forum, I think thinking about the forage base in the back of our mind is always important. So how am I going to do that today? Firstly, I want to look at the recent 12 months and just show what a contrast we've seen. I'll explore the SWOT 21 tool and show you data from that for the last 12 months. I'll then explore the outlook, what's looking forward for the next 3 months or so. And then I want to talk about unusual autumns and unusual cool seasons. I think that's quite important because it has messages for the forage base. And lastly, I'll leave you with a question, and that's really my role, is to get everyone to think about the decisions that they need to make on their property and what information sources are available. So how do you keep abreast of seasonal conditions? So the recent 12 months, a bit like the image in the crystal ball, it seems like it's upside down. And I think that's quite true at the moment. So I want to show how we've transitioned over the last 12 months to be topsy-turvy. And the first way to do that is to get the whole of state picture with what we call the combined drought indicator, which is produced by the seasonal update group in DPIRD. So here we have two maps of New South Wales. The one on the left is around 12 months ago. So I think it's 31st of May last year, and the one on the right is end of April now. So you can see big difference in the map between last year and now. Last year, most of eastern New South Wales was either drought affected or intensifying or a little bit of recovery, whereas now we can see on the right-hand map, most of northern New South Wales is a nice dark green called non-drought. So that's a great sign, that's tremendous. Draw your eye to the bottom part. 12 months ago, Wagga was experiencing drought intensifying. Unfortunately now, Wagga area still in drought, some areas further intensifying and spreading across the southwest. Just keep that little picture in your mind as we move forward. Let's drill into the North West LLS region so we can break up the maps into the North West LLS region, and what a contrast. It's very much like that crystal ball, upside down. This time last year, of the catchment, around 98% of the catchment area was classified as having a drought category one way or another. So that's the pale brown or the stripy. The pale green is recovery. And that little tiny patch of non-drought up near the Queensland border was the only patch that was classified non-drought. End of April this year, the only little patch just east of Manila and northeast of Tamworth that is in the recovery phase. Otherwise, everything else is classified as non-drought. So quite a turnaround in those indicators. How did we get here? Well, for each of the parishes in New South Wales, the drought indicator can be drilled into. So for your very own parish, wherever you are, you can drill into that local area and get a through time look at the drought histories. So I want to just focus in on 3 locations across North West LLS, Walgett, Wagga's on my brain. Walgett, Coonabarabran and Tamworth, to contrast what we've seen occur over the past 12 months. So here, firstly, the chart for Walgett. Draw your attention to the vertical red line. That's 12 months ago, end of April last year. So that just gives you a reference point of that whole time sequence. So there are 3 indicators in this panel. One is rainfall, that's the blue. One is soil water, which is the purpley colour, and one is the pasture or plant growth index. So these change through time, and these are long-term indicators. They're using values over the past 12 months, so they're a bit slower to change than what we see day to day. When those indicators get below certain thresholds, that'll trigger the drought ranking. So whether it is drought affected, whether it's drought intensifying, so the indicators are still going down, or whether the indicators are starting to turn and come back up to be relieving that pressure. Okay, so what do we see at Walgett? Around November 2023, you can see on the bottom panel, this darker orange colour, classified as drought. Then we spent a lot of time in either drought intensifying or reducing. Finally, there was a transition around June 2024 going into recovery, and then from around September 2024 it's been classified as non-drought. So you can see there's a nice gentle rise in the indicators over time and arriving at that non-drought condition. Let's contrast that with Coonabarabran. So again, same red line there for reference, and you can see a lot of tan along the bottom of the graph there, so drought affected. But you can see a very long phase of lime green. So instead of non-drought, it's been in a recovery phase for a very, very long time. So why is that? I think the key here is the rainfall trace has stayed below median for most of that time, and it's only in the last month or so where it's kicked above the 50 percentile, so kicked above median levels. So the transition in Coonabarabran has been slow and steady. Contrast that with Tamworth. The same sort of pattern is in the middle of the graph, right? So there's a long, broad stretch of tan in the middle there near the red line, but then things turned around quite rapidly. Rainfall index went up sharply, soil water index went up sharply, plant growth index went up sharply. So it was a very short transition from that lime green recovery into non-drought. But there's one thing that I would draw attention to for this, and it's a bit of a double-edged risk. The rainfall trace in the indicator has only popped up above median with that April rain and has already disappeared back below median level. So I think it's quite on the edge in terms of where it could go. It wouldn't take much of a drop-off in rain for the drought-affected condition to return. And that's why we want to look at the soil water 21-day tool, because it's dynamic. It's much more dynamic. So the SWOT 21 tool, it's not a SWOT squad. It's a simple water moving average over 21 days. So it's far more dynamic, and it's far better at detecting those rapid drying events, or indeed those rapid wetting events across the catchment and across the state. The web page there for the seasonal update will take you straight to that seasonal, the short-term dryness indicator. But the point about this is that it's relative to the soil in that area. So is the bucket, for want of a better term, is the bucket half full, 3/4 full, or 1/4 full or less? So it's ranking the amount of water in the system on that basis. If you have a light soil, it can very quickly transition from being full to very empty. But a heavy soil will probably take longer. So I'm going to run you through the past 12 months for New South Wales, and I want you to look at the patterns occurring across the state. And I want you to put in your mind, how could this information be useful to me? I think there are some opportunities here. So if we go back to May last year, the darker the colour, the higher the relative water. That's the simple message. And it's all in percentage levels. So dark blue is 100% full, and that really pale grey colour is in the bottom 10 percentile. So you can see there, poor old Wagga, May last year was in that bottom 10 percentile. So there no soil water in the system there at all. And you can see in the southwest Mallee also in that pale colour. But the rest of the coastal fringe across broad areas of central New South Wales, things were not too bad. Now just think about it. Where do you store livestock or store animals from? Where do you pick up weaners from? Where might you be sourcing them? You could look at this graph and go, ooh, conditions are a bit tight down there where I normally get them. Maybe there's an opportunity to pick them up earlier. You know, there's ways that this information can be used. So keep that in the back of your mind. Let's go through. May, that was May. June, we see the winter rainfall really having an effect along the ranges, and tablelands. July, across most of New South Wales is looking pretty good, apart from probably the northern tablelands, the very northern part. August, we can start to see the drying pattern come in across the state from the west. End of September, big shift, okay? So back to, which way am I going here? Let's see. Back to August, and then by the end of September, big drying trend across most of the state. Now, in all my research that I've done over the years here, I always have a rule of thumb that it's very difficult to accumulate and retain soil moisture in our system come September. So once September comes onto the calendar, I'm expecting to lose soil water. And it's really interesting that this product has clearly shown the same thing. Okay, so October, more drying. November, more drying, a bit of north coast rainfall. December I thought was a real critical point around here. Things really dried off. The drought indicator didn't show that, but this product did. And it clearly shows a lack of soil water across the system for most of New South Wales. Then comes the eastern rainfall influences up and down the coast and ranges. A little bit more extensive in February onto the tablelands. Alfred, Cyclone Alfred, depositing bucket loads of rain in the north. You can see that area around Young, Cowra in the southern central starting to dry off. And as at the end of April. So still nice and moist up on the north coast and northern tablelands, but you can see the extensive pale areas now down around that Wagga area and in the far west Mallee. So that's a pretty good picture, I think, of how quickly conditions can change in the soil water realm. This is a new product out of the seasonal update unit. I'd welcome any comment back to me that I can pass on to them, but I like to put it in context of my local knowledge of the information coming through. So happy to talk to anyone about that. So what is the outlook? Who's checked out the 3-month outlook? Not too many hands coming up. I'll look at the drought forecast, which is a 3-month outlook, and I'll look at the usual rainfall and temperature outlooks. So the seasonal update group in DPIRD now produce this product. There's 4 maps there of New South Wales. The top 2 are probably the two to keep in your mind. The top left is the current conditions for the drought indicator, 30th of April. The one on the right, the top right, is the projection for 3 months from now. So you saw how rapidly the soil water tool was showing the depletion of soil water across the state, particularly in the southern parts. And you can see that the projection for the drought indicators 3 months from now are mimicking that pattern. So you can see right across the southern part of New South Wales, drought conditions unfortunately are forecast to persist and in some cases get a little bit more intense. Good news for us in North West LLS is it's still predominantly green, non-drought. Apart from that little area east of Manila and northeast of Tamworth going up onto the slopes. The bottom two panels are there for reference, and they are important because they present how these projections are arrived at. The blue one on the bottom left is how accurate, how much agreement there is between the various models. So the darker the blue, the more agreement, which is great. But the panel on the right says, well, how accurate has it been in the past? And the paler the colour says, maybe not so accurate. So they are important for reference. Okay. 3 month rainfall and temperature outlook. Bottom line for us in the northwest for the rainfall outlook is 50-50 chance of median. So flip a coin, is it going to be above or below median? The panels on the right, they're a very dark red colour. What they are saying is that the probabilities of minimum temperatures and maximum temperatures exceeding median values is like 90%. So they're saying warmer than normal winter. Okay, so both minimum and maximum temperatures to be above median. Now this is where I want to draw these pieces together to get a bit of an inkling of what that means for our forage base. We're not sitting on a bucket load of soil water reserve, as I showed you in those maps, and they were declining quite sharply. If minimum and maximum temperatures are forecast to be well above average over the next 3 months, and rainfall is 50-50, flip a coin whether it's going to be around median, the impact of the evaporation on our stored soil water reserve could be quite squeezy. So the next 3 months, the median rainfall is around 100 millimetres for Tamworth. The evaporation, the average evaporation rate over those 3 months is about 160 millimetres, 1.6 to 1. So you can see that even in our cool season, the evaporation demand is so strong that we can quite effectively utilise and deplete our soil water reserves. So I'm seeing a note of caution in these data. But it begs the question, what is normal? Is this normal? I want to look at the typical pattern of what I've seen in my data over the years in terms of the soil water pattern as it aligns with rainfall. And then I want to drill into recent years and just see how normal they are. This is my version of normal. Everyone has their own version of normal. My version of normal, January to December, monthly rainfall for Tamworth. You can see a nice dip in the rainfall from warm season to cool season. This dark blue line is total stored soil water in my experimental plots that I've measured time and time again. And what we tend to see is April and May is our lowest ebb of stored soil water over the year. And typically, that's why around here we have a bit of difficulty getting our annual legumes going because they're trying to germinate in a system that's basically dry at that time of the year. Very different to the south where we expect that reliable break. Now, the next graph should cover everyone in the room. I pulled together the last 50 years of data for Tamworth to drill into what is the total rainfall in each of the autumns for the last 50 years. I think I'm safe. I don't think anyone's going to be referencing pre-1975. On the right-hand side is a red box, red line going across the middle. The red line is the average, 135 millimetres on average in the Tamworth rainfall record for autumn. The box on the right is the last 6 years. The last 6 years, we've had consecutively above average rainfall in autumn. And the red star is this year, and it's not finished yet. It's still raining. So that bar is going to grow even more, but safely confirmed 6 years in a row where autumn rainfall in Tamworth is above average. Who remembers the late 1980s? 1, 2, 3, 4, 5, 6, 7, about 8 or 9 hands. I first came to this area in 1988, so I only just remember it. It was my first year at university. So we have to go back to that period, the 1980s, late 1980s, to see a run of years where autumn rainfalls have been above average. What about winter? Same period of time, but now collating the rainfall for winter. So in the recent period, there's only 2 bars there that really stand out as being well above average. One was just above average. 2015, 2016 was another one. But again, you probably have to go back to this period here in the late 80s where there was consistency of winter rainfall. And anyone who remembers the sub and super years probably knows what I'm talking about. So if you pull autumn and winter together, same thing, you can see 4 years in a row, this one's still counting. If we even get roughly near average winter rainfall, we will have the 5th bar in a row of above average cool season rainfall. So it has messages, it has meaning. How do we manage the forage base in this environment when we run through years that are excessively dry, then backflip into excessively wet, but not only excessively wet, the season of the rain changes from summer to winter. How do we manage the forage base in that? Well, the message is that no single forage type covers all years, does it? So our experience in SGS and the Evergraze programs and working in the tropical grasses, we need a compendium of forage sources on the property in order to meet livestock requirements throughout the year, because we just never know which season is going to deliver us that above average rainfall. But as the gentleman was just saying, how have recent years impacted our forage base? Really not sure on that. The 2016-19 drought was devastating to anyone, I would suggest, that had temperate perennial grasses in their system. They didn't like that very much. But I will say that the tropical perennial grasses persisted without too much of a problem. They're very good at handling those drought conditions. So I've clearly shown to you that the autumn rainfall and the winter rainfall secondary over the last few years have been quite exceptional. So what has that meant? It's meant that having a crack at establishing temperate perennial grasses in recent seasons has been incredibly effective. And I've heard a lot of comment about, why aren't we growing more temperate perennial grasses? This is great. And I would say there's a very strong word of caution, because these recent years are not normal. Normal is that graph I showed you with a big dip in it in the autumn time. So the experience from DPI over many years that we've really struggled to maintain temperate perennial grasses down on the slopes and the plains. And one of the key reasons is our summer rainfall. There's a little photo of Casbar Coxfoot. It's meant to be summer dormant. That photo was taken in January. So a little bit of rain in the warm season tricks the grass into thinking, oh great, autumn's arrived, I'll start growing. But all that does is deplete the reserves out of the plant, because then it goes dry again and those tillers are lost. So how do you keep abreast? I would always suggest your primary source of data is your own rain gauge. It's the best source of information for your property. So it's a primary source of information. But the seasonal update, available on the DPI website. The farming forecaster platform, it's increasing its reach. So more sites are being established in the North West now. So it can have projections of soil, water and pasture. The Bureau as normal. And for contacts, there's my contacts if anybody wants to get in touch. Picture on the left will be welcome news to many, and that is tropical pastures for livestock production in New South Wales is coming soon. So we've sent our draft off to MLA, and MLA is sending that out for review. So it's getting another step closer to the long-awaited return of the revised Tropical Grasses book, which people will be familiar with. Just like to acknowledge the seasonal update people, Kim, Jen and Kel, for helping compile some of those panels. And that's me. Question was, what's happening with spring? I only showed the autumn and winter. Good question about the spring. I didn't leave it out for any ulterior motives or anything like that. The springs have been variable. They haven't been consistent like we've seen in prior periods. So yeah, we've had experience where springs typically cut out. So yeah, go dry too quick. So depending on how the springs go, I mean, they have implications, particularly for our annual temperate legumes, whether they're going to get to seed set and so on. But I wanted to focus on the autumns, particularly the autumns and the winter, because that sets up the cool season, right? So in this recent phase where we've just had back-to-back above average years in autumn, it just creates a very different feeling to the way that the systems are running. So that's why I focused on those rather than springs.
Thanks for an interesting presentation. I was wondering, I know you're a water scientist, so excuse me for that, but as the winters get warmer and we've got more water available, what does that mean for our pasture production? And should we be, like, is there different pastures we should be planning to, that will utilise that warmer conditions over winter, or is we going to, what's the interaction between water and pasture in winter time?
Well, it's not normally typical that we have this much water available in winter, so that's certainly not the norm. What that means to me as a hydrologist, pasture hydrologist, is we just use it faster. So whatever reserves we have, we chew through it faster. Now the growing degree days is going to have that impact on the relative growth we get out of the system. But the point is that we'll utilise those resources quicker. And experiments that we've had where we've had high levels of fertility in a pasture system, and the rate at which that high fertility system has utilised water, yeah, it becomes stressed first because it utilises the water so much quicker.